design a fitness track. Yay! Sounds like fun.
Yep.
Is there any sort of overview you want to give me on this? What do you think?
Hi, Monica. We are going to do another system design mock interview. Today, our topic is strava. Well, I never use strava, but it's a similar app, similar like Apple's activity or other activity tracking app.
Now, I'm not an Apple user. Can you name another program that a PC user might know or an Android user might know?
Android. For Android, Meta has a similar competitive product called Fitbit.
Oh, okay, so this is like Fitbit. Got it.
Yeah, so with that, users would be able to create an activity with selected activity type. For the simplicity, we would only consider run or bike in this interview. Once they create it, they can start, pause, stop, and save their activity. During an activity, users should be able to view their live activity data such as routes.
Can you summarize instead of telling me all the different features?
Users should be able to view their activity details, and after the activity completed, users should be able to view their own activity and their friends.
Oh, so you can share it with your friends.
Yeah.
Okay, that's pretty interesting. Okay, I've got it. And do you want to give me any prompts or directives for my note-taking during this mock interview?
First of all, always focus on the logic. Am I telling the story so you can understand?
Yep.
And then verb, subject agreements, grammars.
Grammar is uncountable.
Yep. And first, let's see what the non-functional or quality requirements we need to fulfill are. First, we value availability over consistency, which means at any time we want the app to be available for the users, and users would be able to understand if the data have a few seconds delay. And we support activity tracking with low or no network. And we support the activities can scale up to 10 million because we allow 10 million daily active user. That to the maximum we would possibly have 10 million concurrent activities. And we should be able to, users should be view up to date activity details. Users should be able to view their details during in the real time with their own activity.
You still there?
I'm still there.
You thinking? Oh. I can't see you, so.
You can't see me?
Mm-hmm.
Okay, now let's go to core entities. The first one, users, of course, and then their friends, and then activities, and then not last but not least, their roots. But these could be a features could be a field activity. APIs. So the first user should be able to create an activity that will be post API call with endpoint activities with activity type. And once they create an activity, they would be able to update I would use patch, but a patch would allow the user to update a single activity field. Post would also work here as long as user provide the whole activity details. Activity ID, and we have informations like status, whether the user is pausing, resume, or stop the activity. And user would be able to view activities. Get activities, and they can view either their own or their friends, and we support pagination, so they pagination. And return a partial collection of activities. And the user would be able to update their routes. It would include like informations like their latitude, longitude, time steps. The field longitude and latitude is GPS coordinates. And timestamp, of course. Okay. Single users ID. Okay. Besides view a list of activities, user would need to view a specific activities detail. Get I'll just copy this to make it faster. It will return an activity and all the routes data. Route data. Go next. How will the user be able to start, pause, stop an activity? First, the user interacts with their mobile application. We call it our client app. Client, and the client app send a update activity requests with the actions are like start or pause or stop or save to the activity server. Activity server, and the server interact with the database. And the database have activity table. Once the user create an activity, the activity should contain activity ID, which is the primary key here, and user ID, and type, whether it is a run or jogging or other type of activity, type, start time, end time, route ID, and event update JSON file. JSON, like when the user pause or resume the data, we would append an event to the event update JSON, and that's the server would return this activity to the user. So I would change the arrow to be double-headed. How can users view live statics from their current activity while running, or view live statistic? We would utilize the mobile phone's GPS features. These days, the smartphone all support GPS tracking. Here we go. Okay. Please, GPS. Once a user starts an activity, the GPS starts to periodically records the longitude, latitude, and the timestamp and send to the server. And the recorded time locations can also reflect on user's application. In this case, user would be able to view their live statistics. When in the same time, the client would also periodically sync the live statistics to the database through the application server. So I would add a API call, update routes, include route ID and other informations. ID, longitude, latitude, timestamp. And we would calculate the distance based on the route. For a long bike ride in particular, recalculating the total distance based on routes can be expensive. How can you make it more efficient? Calling the server periodically is an expensive calculation, and especially we always calculate the distance. To avoid this, we can run all of this on the client application. These days, mobile applications are quite powerful. We can add every time when the GPS sends a new coordinate, we save it in memory buffer, And then to avoid this buffer get lost, such as due to app crash or loss of network, we save the activity data into a persistent storage on the phone. And if there is a app crash or something, when the app restart, the app should first request ongoing activity data within the persistent storage. In this way, we eliminate information loss. And to avoid recalculating, we should use incremental approach, which means on every coordinate updates, we calculate the incremental distance with the previous coordinate using a geographic formula, because the Earth is a sphere, not a flat grid. So we should use geographic formula such as hovering calculation. In this way, we don't need to recalculate the total distance in the end, and when the client stops the activity, we can save the total distance to the server, and the server would update the database. How will users be able to view details about their own and their friends' completed activity? In this case, users send view requests, send a get request to activity endpoint with either the mode equal to user or friends. Whenever a friends relation is created, we save the friends relation bidirectionally, so that when we query the friends database, we can quickly find the both side friendship. Whenever a user requests a friends mode, we first query all the friends of this user and then join all the friends activity and return to the client application. First, we filtered activity status as equals completed and return to the user. Oh, okay. We should be able to finish.
We have time.
How will your system support tracking activities while user devices offline? As we have mentioned it, we rely on mobile phones, GPS features, and we save activity routes update in memory, and also persistent storage. In this way, we avoid relying on the server to track the activity updates. whenever the user device is back to online, the app can sync the persistent storage on the app to the database. In this way, we wouldn't lose any information. Besides local tracking, we could also do the calculation part on device, like calculating the total distance, like average speed on the device. In this way, we don't need a server to calculate those information. How can we support up-to-date share activities with friends? To support up-to-date sharing activity, the system needs to go back to the periodic sync with the server, as opposed to totally rely on the mobile device. To allow sharing, first the app periodically sync the data to the database. When it is a run, we can use like 5 seconds. When it's a bike, we can use a shorter time period. And then in the same time, we all the friends application need to start to polling the information to avoid the delays. We can, like for example, user update the data every 3 or 5 seconds, depends on the activity type, and friends application poll the information with a like maybe 1 second delay. This would enable a smooth live sharing, and we also avoid the expensive and complicated WebSocket implication, because in this way we know the time sharing pattern. We do this for all the in-progress activity. Well, how can we expose up-to-date leaderboard with top athletes globally based on the total distance covered? If we need a leaderboard with all the top athletes globally, then we need a data structure that quickly sort all the athletes' performance. In this case, a database, every time we query the database and calculate the score would be very expensive. To solve the problem, we can rely on a Redis sorted set, which we can use we use activity ID as the key, and then their total time as the score. In because sorted set use skip list, which allow a one-time complexity level of insertion, so very quick, and return the sorted list to allow like country to allow letterboard of each country. We can add a key such as activity and colon country. In this way, we would enable country level letterboard. There's a problem of there's a country of bringing in Redis, that is to synchronization between the main database and the Redis. So we would either use a capture data like a CDC to write into the database and the Redis. We could also have a time. Yeah, I think that's all. We just need a bi-directional synchronization between the database and the Redis to avoid the inconsistency between the main database and Redis. Okay, we finished.
Wow. Well,
Oh.
that was interesting because there's so much real world language in that description as opposed to some of the more technical things that you've explained to me. It was actually a much more challenging subject-verb agreement content.
Do you want to
because there's
switch?
a lot more real world, but you did very well. So I'm going to change rooms. We'll come back and we'll look, okay?
Mm-hmm.
Be right back.